All right, today we are in chapter 7, and we're going to begin working on this packet together, and then the homework for tonight is to finish the problems in this packet. We'll go over them tomorrow. I will have my full key for the packet posted so you can check your answers. All right, so we want to be able to find the area between two curves. So prior to this chapter, when we were finding area underneath a curve, we were always finding the area between a curve and the x-axis, right? And so now we're just cutting that short. If you think about this picture, in previous chapters, we have found, say, between these values here, A and B, we've found this entire area, right? All of this. If I want just the area between f of x and g of x, all I would really have to do is say, find the area between f of x and the x-axis, find the area between g of x and the x-axis, that, and if you subtract out those areas, you should be left with the yellow portion, right? So that kind of logically makes sense. And so for that reason, if we're trying to find the area between two curves and f is on top of g, then that area is going to be a definite integral of the area between a and b of f of x minus the area of g of x. So what I just said, but in calculus notation. And you can kind of think of it generally, basically, instead of thinking f and g and all of that, just think of it as the area between, the area is the integral between a and b of the top function minus the bottom function. All right, so let's look at an example here. This one's already done for you, so we're not really adding to this. If I want to find the area between the x squared curve and the x cubed curve, the first thing I need to find, which likely will not be given to me, are the points of intersection. Like, what are the a and the b? So first of all, I'm going to say find the bounds, or find a and b, the lower limit. That kind of looks like an ordered pair, but I'm just saying find the lower and upper limits, these guys. Limits of integration. Okay, and then take a note that when you're looking at the graph, the x cubed graph is the bottom function and the x squared graph is the top function. So to find that area, it should be the integral between 0 and 1. And again, that was, sorry, I should say this. How did they find these points of intersection? They set x cubed equal to x squared. If you want to solve a polynomial function, you need to remember to get it equal to 0 factor. And that is how they got 0 and 1. Sorry. Anyway, so you're taking the integral between 0 and 1 of x squared minus x cubed. So x squared becomes x cubed over 3. X to the third becomes x to the fourth over 4. You're subtracting those and evaluating from 1 to 0. The rest is just plugging in your values. The area is 112. Okay, seems reasonable, right? This one's different. What if we are looking at the area bounded between two regions and the equations are in terms of y, they're functions of y? This first example back here, these were functions of x, because the equations back here, the equations were in terms of y equals x squared, y equals x cubed. Here, it's x equals 1 minus y squared, x equals y squared minus 1. So leave them in that form. The first step is still to find your bounds. So you first need to know, well, when is 1 minus y squared equal to y squared minus 1? If you solve for that, you'd get 2y squared equals, add 1, you get 2. Y squared equals 1. Y equals plus or minus 1. So that you can see it in the graph, but that shows you that, okay, the integral is going to go from -1 to 1. And instead of top and bottom, because there's no top and bottom, what you're doing is finding the area between the y-axis and the curve that's in terms of y. And it's always right minus left. Just think about that. The area on the right is going to be positive, and the area on the left, it's to the left of the y-axis, which equates to being below the x-axis, if you think of it that way. That area is negative. And I want the total area here. So we're doing a positive minus a negative. So that's why it's going to give me the area between those two bounds. If I did left minus right, I'd get some sort of a negative area, and that's not the case. All right, so if you look at their integration, everything's in terms of y. We're going from y values of -1 to 1, and they set up the integral of the function on the right minus the function on the left. Everything's in terms of y, so dy. That can be simplified before you just start integrating. So the integral of 2 is 2y. The integral of y squared is 2/3 y cubed. And then plug in 1 and plug in -1 and simplify. That area is 8/3. All right, last one we're going to look at without just actually solving it ourselves. So I want to find the area between the two curves, and here are the two curves. Y equals 0, which is also known as the x-axis, and y equals 3x cubed minus x. Well, this is what we've been doing, right? We did this back in chapter 4. You need to be looking at the graph and say, well, when is 3 times x cubed minus x, when is that equal to 0? That's always your first step, is to find these bounds. I can factor out an x, and I can get solutions of 0 plus or minus 1. And then you do need to think about the graph or look at the graph here. So here are the bounds, -1, 0, and 1. The reason the graph is important is because it will help you kind of visualize the signs and stuff, thinking top minus bottom. So everything's in terms of x. I'm thinking, okay, I need the integral from -1 to 0 of the top minus the bottom, dx. And then I need to add to that the integral from 0 to 1 of, again, the top minus the bottom. In this first chunk, the top is the green curve, right? The 3x cubed minus x, and the bottom is 0. In the second curve, the top is the y equals 0 line, so that's why it says 0 here, minus the green curve, which is the 3 times x cubed minus x. So it is important to think in terms of top minus bottom. And the reason you need to know what the graph looks like is so you know which function is on top. The rest is just plugging in taking the antiderivatives or finding the antiderivatives, plugging in the numbers, and getting the answer. All right. And again, sorry, I want to point this out. These are not net areas. We have a subtraction going on here. So the reason we're doing top minus bottom again is because that gives us, top minus bottom will give us a value that we're saying like so this comes out to like minus -3/4. That's going to add 3/4. So this -3/4 area is being added, making it positive, adding that to the other area, which was positive 3/4. Okay, so this is a total area. It's not a net area. The net area, looking at this, net area would be 0, right? Okay, let's do one that hasn't been worked out for us. Find the area of the region between the graphs f of x and g of x. Everything's in terms of x's, so in general, I'm thinking top minus bottom, everything should be dx. The first thing to do are find these points of intersection. So the first thing I always do is set the functions equal to each other. And I need to solve for x. This is polynomial, so get it equal to 0. If you add x squared to this side, the x squareds cancel. If you subtract 2x from 10x, you get -12x. And then you can factor out a 3x. X equals 0 and plus or minus 2. The graph, again, is important because we're thinking top minus bottom. We need to know what's on top and what's on the bottom. So, okay, right here, this is -2. This is 0, obviously. And this one is positive 2. Okay, so we're looking for this area and this area. So the area on the left is the integral from -2 to 0 of what? What's on the top, what's on the bottom? The top function you should be able to identify as the cubic. So that's 3x cubed minus x squared minus 10x minus, always subtract with parentheses so you don't forget to distribute a negative. So minus the bottom function, which is the parabola. So minus negative x squared plus 2x. All of that gets a dx. Add to that the integral from 0 to 2 of what's top and what's bottom. Here, the top is the parabola and the bottom is the cubic. So here it's negative x squared plus 2x minus parentheses 3x cubed minus x squared minus 10x dx. Let's combine like terms before we start integrating. Negative 2 to 0. All right, so what do we have here? We have 3x to the third. Negative x squared plus x squared cancels. Negative 10x minus 2x minus 12x dx. Don't forget your little details like the dx. Add to that the integral from 0 to 2 of, now we have a negative 3x cubed. Negative x squared plus x squared cancels again. 2x plus 10x plus 12x dx. All right, and then I can integrate from here. So this becomes 3x to the fourth over 4 minus 12x squared over 2 becomes 6 minus 6x squared, evaluated from negative 2 to 0, plus this becomes negative 3x to the fourth over 4 plus 12x squared over 2 plus 6x squared, evaluated from 0 to 2. And then, all right, plugging in 0 is not so bad. Minus, plugging in negative 2, this becomes positive 16 divided by 4 is 4. So 3 times 4 is 12. Minus 6 times 4, so minus 24. Plus, plug 2 in here. Negative 3 times 4 is negative 12. Plus 6 times 4 is 24. Minus 0. This is negative 12, but distribute the negative through, it's positive 12, plus another 12. Finally, we get to the total shaded area. Total area there is 24 units. All right, let's do another one. And I'm just going to keep going until I run out of time in this class period. And then the rest will be homework. Find the area of the region bounded by y equals x cubed, y equals x plus 6, y equals negative 1/2 x. By the way, I keep providing these graphs for you. Often on the AP test, they will provide the graphs for you, but especially in our homework and sometimes on the AP test, sometimes they won't. So we're expecting that you can graph these three functions accurately as well. All right, so let's find their points of intersection. You can't set all three equations to equal to each other at once, but you know, the two lines intersect. First of all, let's look at our region. The region bounded by these three graphs. So the two lines and the cubic. The region bounded by those three graphs is here, right? It's all of that. And there definitely is a top and a bottom. Actually, I'm going to undo my shading here. Everything's in terms of x, so I need to think like, wait, what is the top and what is the bottom? Well, cut by the y-axis, this line is on top of this line. So here's one area. And then after, on the right side of the y-axis, this line is on top of the x cubed. So here's the second integral that we're going to be finding. So when we find our points of intersection, we should set the two lines equal to each other and find out where they intersect. So let's say x plus 6, when does that equal negative 1/2 x? So 6 equals negative 3/2 x, multiply by negative 2/3. So 2 times 2, so negative 4. So this is negative 4. This is 0, obviously, right? We don't, I mean, you can, but you don't really need to look at, wait, when does x cubed equal? Make sure you know which line is which. This is the y equals negative 1/2 x because of the negative slope. This is the y equals x plus 6. Anyway, I don't need algebra to say, oh, that's 0. And then when does the line x plus 6 intersect the x cubed graph? So when is x cubed equal to x plus 6? This is a polynomial. I can't factor it. So remember, we've talked about this before. It's not complete guess and check because you know your possible answers here are factors of 6 divided by factors of 1. So I'm just going to kind of guess, like, what if I put in 2? 2 to the 8, or 2 to the third becomes 8, minus 2 minus 6. That is 0. So I got lucky with my 2 guess. I might have also guessed like 1 or something, but that is 2. So make it an educated guess. You wouldn't guess, like 4, because 4 is not a factor of 6. Okay, anyway, so x equals 2. So I have my bounds, my limits of integration. Now I just need to set up the integrals. And remember, we're thinking top minus bottom. Top minus bottom changes depending on where you are in the graph, which is why the graph is important. So this blue area is the integral from -4 to 0 of top minus bottom. X plus 6 is on top, minus -1/2, so I'm just going to say plus 1/2 x dx. Add to that the area from 0 to 2. Top minus bottom. X plus 6 is on top, minus x cubed is on the bottom, dx. All right, so I can clean things up a bit on this side anyway. I'm not going to rewrite the whole problem, though. It's 3 over 2x plus 6. All right, and then when I find the antiderivative, this becomes 3 over 2 times x squared over 2. So 3x squared over 4 plus 6x evaluated from -4 to 0. And then we have here, I'm going to go in order. Negative x cubed becomes negative x to the 4th over 4. X becomes plus x squared over 2. And 6 becomes plus 6x. Evaluate that from 0 to 2. And the rest is just careful evaluating. So when I plug in 0, I always write this down. When I plug in 0, I get 0. The reason I write that down is because I'm subtracting 0 minus whatever I get when I plug in -4. It's an easy detail to miss, and then it'll throw your answer off. So this becomes plugging in -4. This is 16 divided by 4 is 4 times 3 is 12 minus 24 plus, when you plug in 2, -16 divided by 4 is -4 plus 4 divided by 2 is 2 plus 12 minus 0. And again, I always write that just in case if there is some term that was like, oh, it's an x plus 1. If I would have had a non-zero, I don't want to forget about it. So I always consider that. -12, but make it negative, is positive. -2 plus 12 is 10, and this is plus, so plus 10. So the area is 22. All right, so these really aren't all that bad. It's the same steps over and over. Look at the graph. If you're not given the graph, get the graph. Find the points of intersection once you identify your area that you're trying to find. And then set up the top minus bottom and find the antiderivative. All right, so let's do another one. Here's one that's in terms of y. Find the area of the region bounded by the graphs x equals 3 minus y squared and y plus 1. So first of all, identify those. I'm not sure what y equals. Here's x equals y plus 1. And this parabola is x equals 3 minus y squared. So again, these are in terms of y. We should be thinking, like if you want to think about rectangles, like dy is a rectangle, you can. But just my shading is the area bounded by these two curves. That's this, right? And remember, it's right minus left. So take a look at this graph. Between the points of intersection, which are here and here, the graph that's on the right the entire time is the parabola, and the graph that's on the left is the line. So that makes our job a lot easier. We can just set up one integral here. So the steps are the same. Figure out the points of intersection. 3 minus y squared, when does that equal y plus 1? That's quadratic, so let's get it equal to 0. I'm going to add y squared to the right, keep y over here, subtract 3 to get minus 2. This factors into y plus 2, y minus 1. Y equals negative 2, positive 1. So this y value right here is negative 2, and this y value right here is positive 1. All right, so the area is the integral from negative 2 to positive 1 of right minus left of 3 minus y squared minus parentheses, the line y plus 1. dy, because everything's in terms of y. All right, let's clean that up a bit before we find the antiderivative. So negative y squared minus y, 3 minus 1 is plus 2 dy. This becomes negative y to the third over 3. Oops, not plus, minus y squared over 2 plus 2y, and you evaluate from negative 2 to 1. So plugging in 1 first, I get negative 1/3 minus 1/2 plus 2 minus, plug in negative 2. Now you get negative 8, but there's already a negative out here, so you get positive 8/3 minus 4 over 2, so minus 2, and then minus 4. All right, so you could work within each parentheses, or you kind of work on like, okay, I've got negative 1/3 minus 8/3. I've got negative 9/3, which is negative 3. I've got 2 plus 2 plus 4, so 4 plus 4 is plus 8. And what did I leave out? Minus 1/2. So 5 minus 1/2 is 4.5. 4.5 is 9 over 2. I don't know. That's how I would do it. You could also, but like I said, you can get a common denominator here and figure that out. Same thing here, subtract. You should get to the same place. All right, what if we take the same two functions and we want to find everything in terms of x? So that's where, I mean, life is much harder this way. So I wouldn't do this. Like I would never choose to do this unless I'm told to for some reason. But let's take these same equations, x equals 3 minus y squared, x equals y plus 1, and let's solve them for y. Okay, so I just need to rewrite them so I don't keep scrolling. So it was x equals 3 minus y squared, x equals y plus 1. Let's start with the easy one. Solve the line for y. So y equals x minus 1. So now that's in terms of x. What about this one? I'm going to have to square root. So y squared, add that to the left, equals 3 minus x. When you square root, the question that we need to know is like, well, we get a plus or minus. So what's the deal with that? Well, think about this sideways parabola. The positive square root of 3 minus x curve is this one that's opening up and to the left, right? Because a negative x plus 3, think of it that way, that's one of those special cases. It's a y-axis reflection. It's been shifted to the right. But anyway, it's y equals the positive square root of 3 minus x. And the one that has been reflected both in the y-axis and on the outside on the x-axis, that's this guy. Y equals negative square root of 3 minus x. And this line is y equals x minus 1. Now, if everything is in terms of x, what we're looking at is top minus bottom. Okay, so when do we switch to top minus bottom? Like when does the top and bottom switch? Well, right here, on top you've got the line, on the bottom you've got the curve, and then over here the top switches to the top curve and the bottom is still the bottom curve. So what do I need to know? Which bounds do I need to know? I need to know this in terms of x. I need to know this in terms of x. And I need to know where does it end in terms of x. All right, so when does x minus 1 equal the negative square root of 3 minus x. You can multiply a negative through here. You can square both sides. You can solve the quadratic. Factor. We get two solutions. The one that we want, well, we get two solutions. So the one that we want down here is -1. Mark that right here. What about the x equals 2? So that is when, well, we'll look at that in a minute. Is that right here? Is this 2? So you can kind of verify that by saying, well, when does x minus 1 equal the positive square root of 3 minus x? When I square both sides, I get x squared minus 2x plus 1. So see how this is coming out the same? Even though I didn't have the negative to begin with and I didn't have to change this to 1 minus x, when you square 1 minus x or when you square x minus 1, you're getting x squared minus 2x plus 1, either way. Okay, so yes, you don't have to solve it all over again. You can say, oh, okay, x equals 2. And then what about this end point? Well, right here, what does x have to equal for square root of 3 minus x to equal 0? That has to be x equals 3. Okay, so again, we are thinking top minus bottom. So let me section off my work here. Once I get this all figured out, my first area here is the integral from x equals -1 to 2 of the top function is the line, x minus 1, minus parentheses. The bottom is negative square root of 3 minus x. So yes, it is minus negative and then dx. And we're going to add to that the integral from 2 to 3 of the positive square root minus the negative square root. And maybe you'll simplify that right off the bat, but just for notes, I'm doing this. So this is the integral from -1 to 2 of x minus 1 plus square root of 3 minus x. And over here, we've got the integral from 2 to 3 of, really, this is just 2, square root of 3 minus x. How do I integrate this? I can integrate x easily, -1 easily. This is a little u sub here, right? U is going to be 3 minus x. Let's do this off to the side. The integral of square root of 3 minus x. U is 3 minus x. Du dx is -1. If you need a negative here, you need a negative out here. So it's negative the integral of square root of u du. So when you integrate that, you've got x becomes x squared over 2. -1 becomes minus x. What is square root of 3 minus x becomes? What does that become? It becomes minus, because of this, minus. And then when we add 1 to that exponent, we get the 2/3, 3 minus x to the 3/2. From -1 to 2. And then add to that. Sorry, I ran out of room here. Okay, so over here, it should be the same thing, right? To get this integral, we need to have a negative because of the u sub and a negative. So it's going to be not plus, but minus. And this is the integral of square root of u du again. So 2 times 3 minus x to the 3/2 over 3. Evaluated from 2 to 3. Let's see if I can streamline this a little bit better. All right, so if we're doing this the long way, oh, by the way, these are often calculator problems, so I'm putting you through the headache of doing all this by hand. But as you look through this packet, you'll see a bunch of these are calculator. Usually they tend to be calculator on the AP test. But anyway, let's just power through this one, see what happens. So if we plug in 2, 4 divided by 2 is 2. Minus 2. minus 2/3 times what? 1 to the 3/2. Okay, that's not bad. Minus, plug in -1. 1/2 plus 1 minus 2/3 times, when I plug in -1, I get 4. Square root of 4 is 2. Raised to the third power is 8. Minus, I've got to be careful here, minus what I get when I subtract these. So I'm doing a big brackets. And then what am I putting in each one? Plug in a 3. Oh, 3's nice. You get 0. Minus, maybe my brackets didn't have to be this huge. 2/3 times, when you plug in 2, you get 1. Ah, okay. Not so bad. I was a bit dramatic there. All right, so now what do we have? 2 minus 2 is 0. Good. Negative 2/3. What about this? Let's see. 1/2 plus 1 is 3/2. Minus 16/3. Okay, I don't think I'm going to add that together yet. I'm just going to say minus 3/2 plus 16/3 plus this last part, 2/3. Because those guys cancel. Let's see, negative 3/2 plus 16/3. So negative 9/6 plus 32/6 is equal to what? 23/6. Oh, I might have messed up my math somewhere because I think I got 9/2 on my calculator. All right, so I can double check it. Maybe you're screaming at me through your computer screen. I might have messed up somewhere. I'll have to put a pin in this. Okay, I'm going to get cut off in a couple of minutes. So let's look through the rest of the packet. Pay attention to whether you're in terms of y's, so that you're going right minus left, or if you're x's, top minus bottom. Use your calculator to draw the graph, set up the integral, and evaluate. Okay, so when the calculator is allowed, and on my key I'm showing, I have a screenshot of my calculator, so if you need to look at my PDF key, please do that. Use the calculator on this, and when you find your bounds for A and B, don't round. I may end up making a part 2 video that goes through the rest of this, like, wait, what do I have to do for all of this? But I think you can try it on your own, and just don't round for your upper and lower bounds. Do this one without a calculator. So just pay attention to the directions to see, am I supposed to use a calculator or not? All right, looking through this. Find the area between two curves. No calculators unless stated. So you can see on here where it says calculator allowed, calculator allowed. Okay, so this is a lot of work to do. But remember, on the calculator allowed problems, you're just setting up the integrals and then just getting straight to the answer. Okay, so work on this. I'll figure out where I made a mistake on this guy. You can see it got kind of ugly. My little paper that I have printed out says I got 9/2, so we'll see. But yeah, what I'm really concerned with, or what I want to make sure you're getting down, is just properly finding the points of intersection and properly setting up the integrals. The answer is like 1 point. Setting up the integrals and having the correct limits, that's where most of the meat of all of these problems is.